And welcome back. So in this video we are going to continue our discussion on recursion with arrays. We're going to solve another question as that will help us to better understand how we can use the concept of recursion whenever we are given an array or a list. So let us understand the question. The question is actually pretty easy and it asks you to find the sum of an array using recursion. These kind of question I will be also giving you in an assignment so that you can try and make sure that you are able to test your understanding. So please make sure that you're solving it in a similar way and also try to actually follow the framework the way I'm coding and draw the recursion tree and write the recurrence relation as well. Okay. So the question again is the same, write the recursion relation and draw recursion tree as well. Give head and tail recursion solution. Okay. So now let us see this question, everyone. Let me code this. So let us go here. Let us create a new file and let us type Python. Yeah. So 2.2 sum of array using recursion, right? Great. So I can make some array as a function and let us pass a easy input in this 1 2 3 4 5. Okay, so we can run this. Yeah, everything is running. Now let us break down this problem as well the way we actually see other problems. So let us move forward, everyone. So pay attention what's going to happen. The very first is going to be the base case. So the way I'm thinking of doing this problem is that of course I will have a list here, right? So I will have a list here. I'm going to make sure that I'm able to work on the first element and the rest I'm going to ask recursion to worry on. Okay. So the very first step, everyone, is going to be the base case. So base case is going to be our first step. I think in this as well, the base case is pretty easy. So it can either be that if size is 0, the overall sum is 0. Okay. Rather, I think that's the best base case to take. Okay. Or it can be if size is 1, then we can return the first element. We can just return the first element. So basically L1 of 0. Now, if you actually think about this, this is not the right base case. This is not the right base case. Okay. The reason for that is if our list is empty. Okay. So let me just showcase it to you as well. So if my ln of, and let me make it L1 is equals to 1, return L1 of 0. Okay. So we are going to do something, but I'm going to show you how this is not the right use case. Now pay attention here, everyone. So what's going to happen now is, because the other base case which we took was if size, if size is 0, then we can comfortably say that our sum is going to be 0, right? So that actually helps a lot. Let me just remove it because I'm going to write size is equals to 1, then it is L of 0, else the answer is 0. Now the second thing is I need to actually make a recursive call. So I'm going to call my sum function on the leftover list, and I will assume that I'm going to get my answer. Once I got my answer, then I think it's pretty straightforward and intuitive to understand. I can just make sure that I'm able to do my calculation, which is just adding this thing, right? Sum of L1. Okay. So this particular sum. Now again, let us just code this first and we will understand few things. So let me just say sum of leftover array, some array, and it can be L1 of this. So again, this will get me the answer. The answer can now be sum of leftover array plus whatever is there in my 0, and I can return this answer, right? So yes, I think this should work perfectly well. Let me just run it. We should print the answer as well. Okay, let it save. Yeah, so answer I'm getting is 15. Now if you will actually see, the reason I was saying that this is not a good test case is because the second I make or pass an empty list, it will not be able to handle. Let's save once. Yeah, I'm getting an error. Okay, the error is saying that recursion depth is exceeded. Now the reason for that is because L1 is basically an empty list. It should ideally have stopped there, right? So these are some, I would say, very subtle things which I don't want you all to miss. I know that 95% of students, they will have an idea when I said that, okay, this is not the best use case. but I still want to make sure that each and every one of you understand this very properly, that these are the minute error which actually wastes your time and everything. So I want that when you are learning these things, you are actually very much focused on each and every part of the framework or the problem, the way I've asked you to solve a problem. So with that particular thing, we should actually make sure that we are handling it in this way. Okay, because see, it will actually be keep on calling this function sum of array L1 with 1 is to this. So it will become an infinite call. It will actually become an infinite call. Okay, and I can just show you that as well. So just let me show you the same as well. Maybe what we can do is we can print L1 here. And if I run it now, see, it's an empty list, empty list, empty list. Now, if you are thinking that why this is not giving an error, again, slicing doesn't give you an error. Okay, it tries to give you an answer. Please make sure that you revise the slicing part again. It's a very important concept and we use it a lot. So yeah, with that, I hope this is clear as well. Let me make it, remove it. Let me make it 0. And let me make the sum 0 as well. Okay, and it's gonna work perfectly fine. Now, of course, one more thing, we can even change. So I'm just making sum array 2. We can just, I would say, take it upwards as well. 1 second. So I can just have this thing, the answer here. Okay, answer something like this, and I can just make my answer is equals to answer plus sum array. I can return my answer like this. So here just what I'm doing is I'm just actually, yeah, or let me actually just get rid of this 1 second. Yeah, this one, this is something which I want to do. So I'm doing my work first, okay, and then just calling this particular method. Again, this is not tail recursion. I've already told all of you guys this, that this is not tail recursion still. Okay, don't get confused in that. If I actually want to write a tail recursion code for this, it would be something like this. Again, I would be needing an accumulator. Okay, so let us keep it accumulator, should be fine. Initially, I can take it as 0, right? So if my L1 of my length of L1 is equals to 0, right? Then I need to return the accumulator. Okay, this kind of handles or is the values actually equal to the base case majorly. Okay, else what I will be doing is I'm gonna make sure that I'm adding in my accumulator the 0th element, and now I'm just calling this particular function. So I'm just returning this L1 1 and the accumulator. Okay, this is actually the perfect, I would say, tail function code for this. Once I have called this function, I'm not doing anything after this, right? So in this, I was actually calling this, then I would have calculated answer. Even if you remove this answer and return this directly, I've shown you already in the last, I think some class where we have discussed that this is not going to be the case. It is still a head recursion, but this actually using the accumulator, this is the tail recursion. And we can now actually run on multiple use cases. Let me just do the same. 1 second. Yeah, let me copy this 1 second. Okay, so just let us have 1 2 3 4 5 here. We can do sum array 2 1 2 3 4 5, and we can just call sum array tail with this 1 2 3 4 5, right? Let me run it now. So the answer should be 15 for first, we are getting the right answer. For this it should be 0, we are getting the right answer, no errors. Sum array 2, we are getting the right answer, 15 0, and finally the 15 answer is there. Okay, so I showed you this, but of course again we should be good to even draw, and I should rather draw the, this was an easy question, but as I told you, initially when you will be coding, after code and before running the code, like in between that, you have to make sure that you are writing the recursion tree for your problem. So this is actually how the problem is going to start. You're going to make a call, downwards. Okay, let me make a circle. Okay, not sure why this is making ovals now, but yeah. So we are calling for 2 3 4 5. I know it's easy, but I still want to have that I would say practice, and I want to make sure that you also draw the same. So I'm also spending this time, because now as we will move forward, some of the problems are gonna be a little bit tough, and if you have done this practice of making, I would say, recursion tree, that will actually help you a lot in solving those problems. Okay, so on LeetCode as well, many questions are there where if you actually have this habit of solving with like making the tree, then you will see that yeah, everything is actually happening nicely. Okay, so yeah, now pay attention everyone. This is going to return 0. Now once I get 0, I'm going to add 5 to it, and I'm going to return 5 here. then 9 is going to get returned, then you are going to return 9 plus 3. So I'm adding this first element every time, right? Again, I can handle it via last element as well, totally on you. I would rather appreciate or just encourage you to write the code. If you're able to write that code, it will be really great that you are able to understand. So just write the code by taking the last element. Okay, so slice your list such that you are sending the first to, I would say, first to second last element. Okay, so just you make sure that you are keeping the last element with yourself, and recursion is taking care of rest of the rest. So this is going to return 12, this is going to return 14, and finally we are going to return the answer, which is going to be 15. Now in your tail recursion solution which I have given, what is going to happen is that you have to maintain an accumulator or answer variable. Okay, so you have to make sure that you are making changes into that as we go forward. And again, that because that is tail recursion, you will be doing everything before I would say sending or before making the recursion call, right? So this is again your recursive tree. You are good to write the recursive relation. We have written this or done this in all the forms, right? I don't think we need to see that visually. I've shown you here as well that visually what's going to happen, and this is going to be exactly the case, right? And we are able to solve this question. Now the reason I've taken this easy question and written the code so that I can now build on this. In the next few classes, I will be actually discussing a single question, but we will be doing it in different ways so that I'm able to explain you the complexities which can arise when we are solving recursion and list question, right? And the same actually will be a lot helpful when we move forward and solve questions with recursion and strings, right? So please make sure that till now you're doing all the questions which have been given in assignment. You are watching the recordings again if you have any doubt, and please make sure that you're following the framework whenever you're solving the question given in assignment or any other recursion question otherwise, right? So yeah, thanks a lot everyone. Let's meet in the next class, and we are going to solve much more question to solidify our understanding of recursion. Thank you.